In this question, you're given that S is equal to the set of all the values of t which belong to R, such that this function fx is equal to mod x minus pi times e power mod x minus 1 times sine mod x is not differentiable at t. Then what is this set S? That's the question. So if you try to draw the graphs of all these individual functions. So if you draw the graphs of all these functions, so modulus of x minus pi will have a graph which looks something like this. So mod x graph moved forward by pi units. And if you draw the graph of e power mod x minus 1, so e power mod x minus 1 will have a graph which looks like this. You have a sharp edge here. For this function, you have a sharp edge at pi. And if you draw the graph of sine of mod x, the graph will look something like this. You have a sharp edge here. So if at all there are some problematic points, there would be 0 and pi. So these are the two potential problematic points with respect to differentiation. So let us try to find the values of differentiation at these 2 points. So let us see if this function is differentiable. Let us go with the first principle. F dash of 0 is nothing but limit h tends to 0 f of h minus f of 0 by h, right? So that is equal to, as you can see, f of 0, if you put x is equal to 0, sine 0 is 0. So f of 0 is 0. So directly limit h tends to 0, f of h by h is the value of differentiation. So if this is defined, then f dash of 0 is defined. So limit h tends to 0, f of h is mod of h minus pi e power mod h minus 1 into sine of mod h by h. So what I do is I'll multiply and divide with an extra h. So as h tends to 0, sine mod h by h will be either plus or minus 1 depending on which neighborhood we are seeing. Similarly, e power mod h minus 1 by mod h is also plus or minus 1 depending on where we are in the neighborhood. And mod of h minus pi, as h tends to 0, this tends to pi. So effectively, the value of this whole function will be either equal to plus or minus pi depending on where h is. But as you can see, you have an extra h here. So if you calculate the limit will always be equal to 0, either in the right neighborhood or in the left neighborhood. Hence, you have a fixed value in the right neighborhood as well as the left neighborhood. So the differential is defined at x is equal to 0. Hence, it is differentiable at x is equal to 0. So 0 is not problematic. Now let us go to pi. So f dash of pi is equal to limit h tends to 0 f of pi plus h minus f of pi by h. So if this limit is defined, then differential is defined. So what is f of pi? If you put x is equal to pi, again you are getting 0. So this is 0. So limit h tends to 0 f of pi plus h, if you put pi plus h in the place of x, so you get pi plus h minus pi mod h times e power mod of pi plus h minus 1 into sine of mod of pi plus h divided by h. So mod h by h will be either plus or minus 1 depending on where h is, and as h tends to 0, so e power mod of pi plus h minus 1 tends to e power pi minus 1, a finite value. And as h tends to 0, sine of pi plus h, this tends to 0. So these two tend to finite values. It is being multiplied by 0. Hence, the value of differential becomes 0. So this limit is also defined. Hence, pi is also not a problematic point. Hence, the two potential problematic points turned out to be non-problematic. Hence, this function is differentiable everywhere. Hence, S is equal to phi and empty set is the answer. Thank you.